In part A, notice that each of the three terms has a natural log. So that means that what we're going to try to do is reduce this problem so that we have one natural log on the left-hand side, one natural log on the right-hand side, so we can set the insides equal to each other. The first thing we should notice is that on the left-hand side, we're subtracting the two natural logs, which means we can combine this to be one natural log of the first inside divided by the second inside. And on the right-hand side, the 2 out in front can be brought inside of the natural log as a power of 4. And because now these have the same base, we have x plus 2 over x equals 4 squared, or 16. Now this is a nice algebraic problem we can solve. Multiply both sides by x. Subtract x, so we get 2 equals 15x, so x equals 2 divided by 15. And now we should make sure this is going to work as a solution to our problem. If x equals 2 over 15, that should be fine for the domain of the natural log in this expression and the second expression. So it looks like that's our solution. On part B, notice that there's one term on the right-hand side that does not involve a log. So we're going to suspect that our solution method is going to be slightly different. The first step is going to be the same though. We're going to combine this to be one log on the left-hand side, so log base 2. Since we're adding, we're going to multiply the insides of the logs together. So we have log base 2 of x times x plus 2 equals 3. Or log base 2 of x squared plus 2x equals 3. And now, in order to find what's inside the log, we're going to write this in exponential form. So the base is 2. The power is always what the log is equal to, so 2 to the third power equals what's inside the log. Now we have a nice quadratic equation. We can factor it and solve. So 0 equals x minus 2 times x plus 4. And so we get two solutions, x equals 2 and x equals negative 4. Now again, we should check our answer. So if we plug 2 in for x, there's no problem with our log. However, if x equals negative 4, natural log base 2, or the log base 2 of negative 4 is not defined. Log is never defined at a negative value. So this is not a solution. The only solution to this problem is x equals 2. On part C, we're asked to solve this exponential equation. Because each base is raised to an exponential power, the good first step is to take the natural log of both sides. That will allow us to bring the power down in front, and so we can do some algebra. So in this case, x would be brought down times the number natural log of 3, and then we have 2 minus x, the whole quantity, times the natural log of 4. Now we're going to isolate the x, so 2 natural log of 4 minus x natural log of 4. That comes from distributing natural log of 4 to both terms. Equals x natural log of 3. Add x natural log of 4 to both sides. And so we have x natural log of 3 plus x natural log of 4 equals 2 natural log of 4. And now both of the terms on the left have an x involved, so we can factor that out. And maybe just for fun, let's write the right-hand side, bring this 2 inside, so this is natural log of 16 to 4 squared. Here, this two terms can be combined to be x times the natural log of 3 times 4, so 12. And finally, in the last step, we can divide both sides by the natural log of 12. So we get natural log of 16 divided by the natural log of 12. On part D, we don't have the logs on the same side of the equation, so that's going to be our very first step. We're going to bring the log of 2x minus 3 to the left-hand side. And write this in terms of one log. So now, because we're subtracting, that means it's going to be the inside of the first log divided by the inside of the second log equals 2. Just like part B, we're now in a place where we need to put this in exponential form. The log is equal to the power, so it's power 2. The base is not written here, so it's implied that's base 10. So 10 squared equals what's inside the log. And now we can solve this equation by multiplying both sides by 2x minus 3. So we have 100 times 2x minus 3 equals 5x plus 1. So 200x minus 300 equals 5x plus 1. Subtract 5x, we have 195x, add 300, so 301. So x is 301 divided by 195. And again, if we checked our answer in the original equation, it looks like that's going to be just fine.